Good morning, sir. This is B. Chetana from CSCB. My topic is frequency dependence of polarization. First, what is meant by polarization? Polarization refers to the orientation of oscillations in electromagnetic waves. It is a critical property that affects how waves interact with materials and their environment. Understanding polarization helps in various applications, including telecommunications and imaging technologies. Here, when we observe the unpolarized light, when it hits the polarizer, it becomes faint polarized light. Basics of electromagnetic waves. Electromagnetic waves consist of oscillating electric and magnetic fields. These waves can propagate through a vacuum or different media, each affecting their properties. The frequency of the wave determines its energy and interaction with matter. First, what is meant by frequency dependence? Frequency dependence refers to how a material response varies with the frequency of incoming electromagnetic waves. Different materials can exhibit different polarization behaviors at different frequencies. This phenomenon is crucial in fields like optics, radio frequency applications, and material science. Types of polarization. There are several types of polarization including linear, circular, and elliptical. Each type of polarization can exhibit unique frequency dependent behaviors. The type of polarization can influence the transmission and reflection characteristics of waves. Here, when we observe this graph, there are three types of polarizations: ionic orientation and electronic polarization. When frequency increases, polarization also increases. Dielectric materials and polarization. Dielectric materials can become polarized when exposed to an external electric field. The degree of polarization is frequency dependent due to the material's molecular structure and response time. At higher frequencies, some materials may exhibit less polarization due to limited molecular mobility. Frequency effects on polarization. The polarization response can change as the frequency of the incident wave increases or decreases. At certain frequencies, resonance can occur, leading to enhanced polarization effects. Conversely, at very high frequencies, materials may become less effective at polarizing electromagnetic waves. Applications in telecommunications. In telecommunications, frequency-dependent polarization can optimize signal transmission. Different frequency bands may require specific polarization techniques for effective communication. Understanding these dependencies helps in designing better antennas and communication systems. Measurement techniques. Various techniques exist to measure frequency-dependent polarization, such as ellipsometry and reflectometry. These methods can provide insights into the material properties and their polarization response. Accurate measurement is essential for developing new materials with tailored polarization characteristics. Here, when we observe this picture, there are many types of measurement techniques: analytical estimating, historical data method, time study, work sampling, synthesis method, predetermined motion time system. Analytical estimating. It is used for fixing the standard time for jobs which are very long and repetitive. Historical data method. It uses the past performance data to set performance standards. Time steady. It uses stopwatch and is best suited for short cycle repetitive jobs. Work sampling. Here workers are observed many times at random. Synthesis method. The full job is divided into element or parts. Predetermined motion time system. Here normally three times are fixed for one job, namely normal, fast and very fast. Challenges and considerations. One challenge is the complexity of material responses, which can vary widely depending on frequency. Environmental factors such as temperature and humidity can also influence polarization behaviors. Careful consideration is needed when designing experiments to account for these variables. Understanding frequency dependence of polarization is crucial for advancing various technologies. Future research may focus on nanostructured materials with unique polarization properties. Continued exploration in this field will likely lead to innovative applications in optics, electronics, and beyond. Thank you.